We're back with fractions. Okay, so now we're going to talk about the addition and the subtraction of fractions. All right, so what I want to start off by saying is right now we're just going to start where the denominators are exactly the same. All right, so A over B plus C over B is A plus C over B. Real simple. A over B minus C over B is A minus C over B. So the big deal that I want to draw your attention is that note, I have the same denominators. Because I have the same denominators, the only thing I'm really going to do is I'm going to look at the interaction that we're having for our operation, and I'm going to comply with that. So I have addition here. So in the numerator, I'm going to honor the addition. So we are going to add. Notice that my denominator maintains itself. Is everybody with me on that? All right? Same with the subtraction. We have same denominators. We take our numerators and we interact our operation with the numerators. Good to go? All right. So let's play with some numbers. So 2 over 7. Wow, that's an ugly 7. Hold on. I can't put that up there. All right. So 2 over 7 plus 3 over 7. So we got a 2 over 7, or 3 over 7. So what I'm going to do is I'm going to say, well, hold on, same denominators. So 2 plus 3 is going to give me my 5, and then I'm left with my 7. Everybody good on that? Okay? All right. By the same token, 2 over 3 plus 5 over 3, right, is equal to 2 plus 5 over 3, which is 7 over 3. Okay, now here's the deal. 7 over 3. We got our improper fraction. Is this wrong? No, it's not wrong. All right. However, you may run into, you go and you check your answers in the book, but they don't want it this way. Maybe they want it as an improper fraction, or maybe they want it as a mixed fraction, or maybe they want, so on and so forth. And it's kind of like a dress code, Sometimes you go to a party and they don't want you having sandals on, despite the fact that you're wearing a tuxedo, right? Okay, so with that said, we're going to flip it around. So I know that 7/3 is my answer as an improper fraction, but now we're going to make it into a mixed. So in order to do that, what do we do?
How many times is 3 going to 7?
How many times is 3 going to 7, right? So we're going to divide that out. Let's find out. So we say 7 divided by 3, right? 3 goes into 7 2 times. 2 times 3 is 6. Subtract, I got the 1. So this becomes 2 and 1/3. So I have my 7/3 and I have my 2 and 1/3. And we're going to note that those two answers are equal. And let me write this a little lower just because, there, so it doesn't look like an exponent. Good to go? All right. Questions, comments, concerns? Okay. So, let's look at our subtraction. All right. So 7/9 minus 3 nines. And right away we're thinking, oh my goodness, let's talk about reduction. Well, we can if we really want to, because at first note, we know we can reduce this, but we're not going to worry about that right now, because more importantly, these are what? These are the same denominators, right? So we're going to roll with that. Remember, just because you can do something doesn't mean you should do something. Yes, I can reduce this, but there's no reason for me to do it, so I'm not going to bother with it, all right? So 7 over 9 minus the 3, and let's put this 9 in the middle to make it a little more pleasing. Are we good to go with that? 7 minus 3 gives me the 4. There's the 9, just like that, right? Nice, pretty fraction. So once again, we go through, we keep our denominators as is because they're like, we deal with our numerators, and we're golden. And 1/3 minus 5/3. From here, we know this is 1 minus 5 over 3, negative 4/3, right? We can also say that as we work this out as from before, this would be negative 1 and 1/3. Is everybody with me on that? Questions, comments, or concerns? No? Okay. See you for multiplication.